All right. Where are we? Okay. So, welcome to the stream. This is the Year 12 Maths Methods IA3 paper, practice paper from QCAA. I'm doing this because there was no worked solutions on their website available for the students, so hopefully this video should provide that as well as an explanation as I go through it. Let's get started with question 1, which is, let's have a look. The length of human pregnancy has a mean of 266 days and a standard deviation of 16 days. A random sample of 9 pregnant women was observed to have a mean pregnancy length of 270 days with a standard deviation of 14 days. Right, so this is obviously a statistics question, and we've got some sample statistics versus whole population statistics. So we're asked to identify the parameters and accompanying statistics in this situation. So it's actually a poorly worded question here. You guys might have a better interpretation than me, because you have much better context, but I think they just want us to list the variables, and I'll explain them a little bit. So let's do, alright, so a random sample of 9 pregnant women, right? So for the sample n, which is the sample size, that's the variable representing sample size, that's going to be equal to 9. We have mean pregnancy length of 270 days for the sample. So we use PS, which is the mean of the sample, will be 270 days. And the last variable that we've been working with for sample proportions is sigma. Right, so sigma sample, which is just the standard deviation, is 14 days. Comparatively, we have mean of the population, which is 266 days. That's just from the problem statement. And same sigma for the population from the problem statement is 16 days. There's not much more we can do here. What we do notice is that there is a difference between the sample of the population and the whole population. So we just expect that to differ depending on the sample size that we choose. So we'd expect that as n increases, as this sample size gets closer and closer to whatever the population size was, that these statistics here, the mean and the standard deviation, would converge towards the population mean and the population standard deviation. Okay, let's have a look at question 2. So hopefully question 2 we can actually do a little bit of maths here to get started. Okay. Determine the exact value of the constant k if the function below is a PDF, so probability density function, right? So fx, it's piecewise. So when x is between 0 and the natural log of 2, fx is defined as k e to the 3x, and elsewhere it's just defined as 0. Okay. So determine the exact value of the constant k as a PDF function. So my thinking here, if we take the integral of any PDF function, which is the area under the curve, we should get 1, right? So let's just write that down. Integral, pen out. Integral, this isn't proper maths here, but integral PDF, if we take it from negative to positive infinity, we should get that the area is equal to 1. Right, so in this specific case, we have integral from 0 to the natural log of 2, right? So log base e is just the natural log. It's a better way to write it. K times e to the 3x with respect to x. This here, this integral should be equal to 1. So this should help us solve for k. Right, so let's just perform this integral as we see fit. Okay. Right, so first thing we can do, let's let u equal 3x. So this is called u substitution, and you guys should have done this by now. So if u is equal to 3x, then du dx, so the derivative of u with respect to x, should be equal to 3, right? Which means if we take dx over to the other side, du should equal 3 dx. So using this, we can now rewrite the initial integral, and we'll have 0 ln 2, and now we can have let's bring this 3 across here first. Right, so du on 3 is equal to dx, so we'll use that du on 3 to replace the dx in this one. So we can rewrite the integral between 0 and ln 2 as, what do we got? K e to the 3x, so we'll write k e to the u, and then instead of writing dx, we can write du. Du, and this is on 3. Let's actually, instead of writing that, make it more obvious. Let's write 1/3 du. Right. Now this here is just a number multiplying, so that means we can bring it out front. We can also bring the k out front as well of this integral. Because it's with respect to u, and these two are just constants, we can bring them out front. So integral between 0 and ln 2 is equal to eu du. Right. And now this should be a pretty straightforward integral to perform. We've made our lives a little bit easier by taking some things out the front and using u substitution. So any integral e to the u is just going to be e to the u again. Right, so e to the u ln 2 and 0. Right, so that's really straightforward. 1 to 3 k. And at this point we can sub back in because we know that u equals 3x. So we'll have e 3x ln 2 0. Right, so this is a definite integral between the bounds of 0 and ln 2. So at this point here, we'll just do some substitution and hopefully solve for k. So big brackets. In this first set here, we're going to sub in ln 2. So open up our brackets, sub in ln 2, and we're going to subtract where we sub in 0. So looking here, 3 times 0 is 0, so e to the power of 0 this cancels out and becomes 1. And let's just have a look here at e to the 3 ln 2. So I'll just go do this separately here in red. E3 ln 2. So let's rewrite this to see what's going on. E ln 2 cubed is another way of writing this here, and what we can see is e to the ln 2. If we know our log laws, that becomes just 2, and then we still have our cubed, so that is equal to 8 all up here. So if you know your log laws, this should be pretty straightforward. If we do e to the power of the natural log 2, it just becomes 2. Right? 2 cubed is 8, so let's go ahead, rub that out, and we'll complete the rest here. So we have 1/3 k is equal to, we had 2 cubed is 8, minus 1, probably didn't need to do that, so 1/3 k is equal to 7. Yeah. This is just a normal set of brackets, just square, so last thing, 7/3, so 1/3 times 7 is 7/3 times k, so 7/3 k. And if we recall from the top, I haven't been writing it down, but the integral of a PDF function over the bounds defined here should be equal to 1. Right? So this expression that we've ended up with at the bottom should be equal to 1. So now we can just do last little bit of algebra to solve for k. So if we times by 3, we'll have 7k equals 3. And then if we divide by 7, we'll have k equals 3/7. Right? And that should be that question done. We've got an exact value for k of the PDF function using this little definition here, that the integral of the PDF function should be equal to 1. Okay, so that's the first bit of maths, ignoring that first question. So let's just going to rub this out quickly, and then we'll hop into question 3. Question 3. Alright, question 3. Calculate the expected value for a uniform probability density function px is equal to 0.02. Alright, defined on the interval between 20 and 70. So let's have a look at our formula sheet. Okay, so we got our formula sheet up. And we need to select the relevant statistics formula. So we had a uniform probability density function, and we needed to find the expected value. So that's going to be here, mean. Right? So we'll use this formula here. Ex equals mu, which is mean. So we're going to do an integral between negative and positive infinity, and it's going to be defined as x times px, our probability density function. And let's take that, and we should get our answer. So this is directly from the formula sheet, which you will be provided. Ex equals mu equals integral from negative infinity, or negative infinity to positive infinity, x times our function, our probability density distribution px with respect to x. Right? So let's go ahead and sub in the probability density function that we've been provided with. So we should have x times, so px here is 0.02. Yeah. Oh, and the other thing to note here, defined on the interval 20 to 70. So when we don't actually have to go from negative to positive infinity, because our distribution is only defined between 20 and 70. So that should also make our lives a little bit easier. Alright, so this is a pretty basic integral here. 0.02 times x, we should know how to do that one. We raise the power of x, so at the moment x is to the power of 1, so we'll raise that to the power of 2, and then we'll divide by that new power. Alright, so it should be 0.02 x squared, and we divide by the new power 2. And that's between 20 and 70. So let's go ahead and simplify that a little bit. 0.02 divided by 2 should be 0.01, and that's x. 0.01 x squared between 20 and 70. So now we just have to complete this definite integral. Equals. Right, so in this first set of brackets we always sub in the top boundary, so it's going to be 70 squared, and then we'll sub in this second boundary, 20, to the lower boundary, 0.01 20 squared. Okay, so let's see what we got here. Might use the calculator for this one. So 70 squared should be 4900, and that'll be multiplied by 0.01. So we'll have 49 in this first bit, minus 20 squared is 400 times 0.01 should be 40. Yeah, oh no, it's 4. Use the calculator. 4. Alright, so 49 minus 400, 45. Alright, so the area under the curve is equal to 45. And then in this specific question, this is our expected value for the uniform probability density distribution, px equals 0.02. Alright, so 45, and that should be our answer done here. So just another definite integral computed. Important to note that even though in the formula sheet the bounds are negative and positive infinity, here they've provided the interval for which this distribution is actually defined. So we'll just go ahead and use that interval 20 and 70. But yeah, just computing a definite integral. And let's have a look at question 4. Go ahead and clear that. Question 4. Just got to snip it and put it on the whiteboard. Okay. Yeah. A point of inflection that is also a stationary point is sometimes called a horizontal point of inflection. Let y equals x cubed plus ax squared plus bx minus 1. Determine a and b given that there is a horizontal point of inflection at the point x equals 1. So here we just need to know our definition, because we know that we can locate a horizontal point of inflection using the double derivative and setting it equal to 0. So that should come in handy somewhere. And they've given us a coordinate at the point x equals 1. So what I'm expecting is we'll find the double derivative, set that equal to 0, and we should be able to maybe get a definition for b or a, and then we'll have to do some maybe some simultaneous equations somewhere, or some kind of substitution to get actually values for a and b. So let's just start off. Let's just find double derivative. So to do that, we'll find the first derivative. Right? So y dash should be equal to 3x squared plus 2ax plus b, meaning y double dash should be equal to 6x plus 2a. Is that right? 3x squared plus 2ax plus b, y dash equals 6x plus 2a. Right, so let's set that equal to 0, because that's where our point of inflection should be. And at that point of inflection, we should have x is equal to 1. Right, so 0 equals 6x plus 2a. And then we can substitute x equals 1, because this here is our point of inflection. So we'll sub x equals 1, and here I'll just write let y double dash equals 0, because that's the point of inflection. Sub, oh I wrote a mistake there. Sub x equals 1. Wow, good handwriting. Sub x equals 1. Alright, so we should have 0 equals 6, 1 plus 2a, meaning we can take the 6 to the other side. So we would have negative 6 plus 2a. Right, so a should equal negative 3. So now we need some sort of expression where we can find what b is equal to. Right, so we know that an inflection point here is also a stationary point. So stationary points we can find using this first derivative here. So if we set that equal to 0, and we can sub in x equals 1, and we can sub in a is equal to negative 3, we should be able to isolate b and get a value for that. Right, so using y dash equals 0, because the inflection point is also a stationary point. So the inflection point is also a stationary point. We can write y dash, so we'll write 0 equals 3x squared plus 2ax plus b. Yep, copied that correctly. So we now have a stationary point set to 0. We have an expression with x, a, and b, but luckily we can sub in x equals 1 and a equals negative 3, and we should be able to just solve that for b quite easily. In case it wasn't clear, the reason we can sub in x equals 1 is because a point of inflection that is also a stationary point. So if we know the location where the inflection point occurs, we also know that's the same location as the stationary point. And we can sub in a equals negative 3 because a is just a constant in the equation, right? So that should never change. So let's go ahead and sub in x equals 1 here. Squared plus 2. Let's sub in a equals negative 3 as well while we're at it. So negative 3 and x equals 1 plus b. So 0 equals 1 squared, it's just 1, so 3 plus, this is negative 6, right, so we actually don't need that, plus b. So 3 minus 6 plus b, 0 equals negative 3 plus b, b must equal 3. Right. Let's just check. Yep, that should be it. Right, so determine a and b. Right, so you're doing your exam, you should be writing a equals negative 3, b equals positive 3, and that should be enough. Okay, so that should be that. Let's just clear the canvas and have a look at question 5. Okay. Right, so another inflection point question. Show that there is only one point of inflection on the curve hx equals blah polynomial. Fifth degree polynomial, so that's a bit of a hassle. Use mathematical reasoning to justify your response. Right, so inflection points we know we can find by analyzing the second derivative and letting it equal 0. So let's just start off by finding second derivative, and we'll see how we go from there. Right, so so we'll find first derivative. It's going to be 5x to the 4 plus 20x cubed plus, so that'll be 30x squared over 3, which is just 10x squared, minus 100x plus 5. Now I do these quite quickly, but definitely take your time doing your derivatives if you're not comfortable with them, because if you get it wrong, you're going to have a carried error throughout the question, and it might be harder to solve. So that's our first derivative. So let's take our second derivative, h double dash x equals, so we'll have 20x cubed plus 60x squared plus 20x minus 100. Okay, so that's our double derivative. If we're going to look for inflection points, we should set it equal to 0. So set h dash x equal to 0 to observe the inflection point. And we'll see what we can tidy up here. So 0. Minus 100. So basically what we're looking for to show that there is only one point of inflection, we would want to show that this equation here only has one solution. So by setting it to 0, we can try find the solutions such that this right hand side of the equation is equal to 0. So we're trying to find x values so that this right hand side is equal to 0, and if there's only one real solution to this polynomial, then we will have proved that there could only be one point of inflection on the curve. Right? So let's see what we can do with this right hand side. 0 equals, right, so let's try factoring an x out the front and see what we end up with, because I don't think you guys have solved cubics before. So if we take an x out the front, we might be able to work with what is left in the brackets. So factorization, take x out the front, means we'd be left with x times 20x squared gives us this, plus x times 60x would give us this, plus 20, x times 20 gives us this, and then of course minus 100 left out here as well. Alright, so this is interesting. Now we have 0 is equal to x minus 100. So in that case, x would have to be equal to 100. Or we can have a look at this quadratic equation in the brackets, 20x squared plus 60x plus 20. So one of these things should equate to 0 for there to be solutions. We can have a look I might graph this actually, and we can have a look and see what this expression actually looks like. So I'm just going to use Desmos for our graphing. So we'll put 20x cubed plus 60x squared plus 20x minus 100. Okay, so this scale is completely off here. We got a very thin equation. Let's just see. If it's really thin, we should make this less. Okay, that's a bit better. Okay, so we can see here we've got a solution here to the equation as x equals 1 and y equals 0, obviously. So there's only one solution for this cubic equation. If this was up here or it passed through in another space, we would have multiple solutions, but this graph actually shows that we only have one solution to this expression. We just have to show that mathematically, because I don't think you guys can use graphs as proof. So if we go back to what we're working with here, maybe let's have a look at solving this quadratic, and we'll see if that helps us at all. I'm just going to have a quick look. Okay. So we can tidy up. We can bring this 100 over. So we'll just add that to both sides. So 100 equals x 60x plus 20. Right. So let's have a look. Let's solve this quadratic that's in the brackets. Let's see what that does to us. So negative b plus minus square root b squared minus 4ac on 2a. Right, and in this case we would have negative b, so that's negative 60 plus minus square root 60 squared, so 3600, minus 4 times a is 80 and c was 20, so 20 times 20, 400 plus 4 is 1600 times 4, sorry, 1600, and that whole thing over 2 times a, so whole thing over 40. What does this leave us with? Plus minus, so 3600 minus 1600. I will punch that in on the calculator just to double check I'm not wrong. So we should have had 60 squared is 3600, 4 times 20 times 20 is 1600, so square root 2000, and I'm just going to go ahead and plug this whole thing on my calculator. Here, let's have a look. Negative b. Let's check. Okay. Negative 60 plus minus 3600 minus 1600 over 40 either gives negative 0.38 for the positive solution and negative 2.618 for the other solution. That does not help. 1 second. I see. Alright, this is silly. We shouldn't be solving this quadratic because it should be equal to 100, not 0, so that's actually not going to give us anything useful at all. So let's go ahead and rub this out. My mistake. I'm trying to think how else, other than inspection, they would expect you guys to solve this. To me, it's quite clear, just by looking at it, 20x squared plus 60x plus 20. So if we had, say for example, x was equal to 1, right? Then we could just sub that in. And it would obviously give us 20 plus 60 plus 20 equals 100. So we would have 100 equals 100. Right, so we know that x is equal to 1. We just need to show that there's no other solutions to this equation. So let's see what else we can do. If we solve this part here and get values for x and substitute them in, and we show that it's not equal to 100 for either of the values for x, then that would show that they weren't valid solutions and that x equals 1 was the only one. So maybe we can do quadratic. So we'll solve this quadratic here, and then we'll sub those values into x and show that they don't equal 100, and that should be valid enough. So x equals, so I was onto something, but that's the whole point of this exercise, is it's a live walkthrough. So you get to see mistakes and thinking along the way. Negative b, so I'm just gonna I remember what that was equal to. B squared 60 squared 3600 minus 4 times 20 times 20 is 1600. So 3600 minus 1600 gives 2000. 2 times a is 2 times 20 is 40. And we ended up with negative 60 plus minus square root of 2000 over 40. So we either end up with x equals negative 2.618 or x equals negative 0.38. Right, and in either of these cases, we would sub x into this expression here. So I'm just going to go ahead and do that on the calculator, and we'll see if it equals 100, because that's what we need it to equal for it to be a valid solution. 20 plus 60. Right, so subbing in negative 2.618 does not give us, it gives us something ridiculous like 0.0003. So now let's check by subbing in x equals negative 0.38, and I'm just doing this on my calculator. So I put negative 0.38, 20 times negative 0.38 squared plus 60 times negative 0.38 plus 20, and that equals negative 0.0334. So in either of these cases down here, right, which are the solutions to our quadratic, if we substitute these into this expression, it's not at all equal to 100. And if it's not at all equal to 100, then it's not a valid solution to this double derivative. And if it's not a valid solution to the double derivative, then it can't be a point of inflection. So these x coordinates do not represent a point of inflection, right? Because they're not solutions to this equation. And if we go and look back at our desmos, so our graph, where are we? If we go and look at our graph, we can see that this here, 1, 0, is the only valid solution to our double derivative, right? So go back to our whiteboard, and we can see that this solution here, x equals to 1, is the only valid solution to the double derivative, which means it is the only point of inflection for this original 5th degree polynomial h of x up here. I'm trying to think if there's anything more robust to present here. I think on the exam, the process for this question, take the double derivative, set it equal to 0, factor out this x out the front here, because I don't think you guys can solve cubics, or I don't think they would expect you to solve cubics. And then you can show here that the solution x equals to 1 does satisfy this expression. Right, so obviously if we subbed in 1 here, 100 equals 100. And then you can go on to show that it's the only solution by looking for alternative solutions and showing that these solutions don't satisfy the equation. Alternatively, if we solve this cubic, I believe we will get presented with x equals 1, and then we'll get 2 non-real solutions. So we'll have something with imaginary numbers, but that should be beyond the scope of this maths methods course. And that's why I'm not sure if they did expect you to be able to solve cubics, then it's quite easy to show x equals 1 is the only real solution, as the other 2 are non-real. But I'm not sure if you guys have done imaginary numbers, so this should be something along these lines should be enough for this question. I'll come back to it if I think of anything else, but that should be fine. So let's clear this let's just move over here. And let's have a look at question 6, I guess. Right, we got another the life expectancy in days of certain bacteria is represented by the probability density function p of x equals 1 over x squared when x is greater than 1 and it's equal to 0 for x is less than 1. So that's a piecewise function again, and you guys, I assume, have looked at these because that's what all these PDF functions are. So p of x equals 1 over x squared when x is greater than or equal to 1, and 0 for x is less than 1. So that's just defining our function. Determine the probability of the bacteria living for more than 10 days. So with probability density functions, if we want to determine the probability, we'll just be looking at taking an integral, and we'll set the boundaries of the integral such that we can get an answer for the question. So it's more than 10 days. So I'm thinking we take an integral of our function with the lower bound being 10 and the upper bound being infinity. Px dx. And I'll just refer to the formula sheet to make sure I'm not missing anything here. What are we looking for? The life expectancy in days. Determine the probability of the bacteria. Right, so it should just be the probability of the bacteria. We should be using this equation here. Oh no, wait. Oh no, it's not expected value, it's just the life expectancy. Oh, we can just use, I think we can just use the probability density function they provided. I don't think you have to use expected value or anything like that. Let me double check. No, I don't see why we would, because we're not doing expected value, we're just finding the probability of a certain scenario. So we should just be able to take the integral of this probability density function between the bounds 10 and infinity, and we should have an answer, because that's how the PDF functions work. So let's go ahead and do that. So another definite integral. So hopefully you guys are good at doing these going into the exam, because it looks like you're going to have to do a lot. So 1 over x squared, let's just do this in steps, I don't want to be confusing. So 1 over x squared is the same as 1 over x to the negative 2. I'll do this in red, I'll do it in red. So 1 over x squared equals 1 x negative 2. So when we do the derivative of that, we would have negative 2 comes down, and then we raise this power by 1, and then we can rewrite it down. So it would be, oh sorry, we're doing integrals. My mistake. Complete wrong direction. 1x negative 2. So we'll raise this power by 1, because that's how we do integrals, and then we'll divide by the new power. So it should be 1x negative 1 divided by the new power. So we should have something like negative 1 over x. On my calculator as well. So yeah, so negative 1 to the x, this here will be our integral that we're going to use. Right, so write this out now. Right, so definite integral between 10 and infinity of negative 1 over x So now we're going to substitute in, and as always the top boundary is the first to be substituted in. So instead of writing x, we're going to sub in infinity, and then we're going to minus from the lower boundary negative 1 over 10. Right, so this here, something divided by infinity is just going to converge to 0. Right? Because it's such a big number, it's just going to converge to 0. And here we'll have negative times negative 1/10, so we should have positive 1/10. Negative times negative is positive. So here is our probability that the bacteria lives for greater than 10 days, right? So probability bacteria lives for more than 10 days equals 1/10. And let's have a look at a graph for this as well. So we'll go back to Desmos and we'll just graph -1 on x squared and 1 on x squared, sorry. I believe. Yeah, 1 on x squared. Now this scale is a bit wrong. So let's see. -10. Okay, that's a tiny scale. Right, so what we just found there, we computed the integral, so the area under this curve, but only from 10, this tiny little sliver here, all the way to infinity. So obviously I can't scroll over to that. So we just found the area under this curve between 10 and infinity, and that should give us the probability that the bacteria would live for more than 10 days. Okay. Let's have a look at the next question. So that should be it for this question. Question 7. I'm just going to take a second to check the live stream to make sure it's working, because I don't want to be hopefully not doing this to no one. Okay, yeah, that's working. Okay, reset the music. Yeah, geometry question. This should be a bit more interesting. What do we got? Diagram below shows a trapezium-shaped window. 3 sides of the window are 2 meters long, so 2, 2, 2. The angle between the sloping sides of the window and the base is theta, between 0 and pi on 2. So that's radians. Pi is equal to 180 degrees. So this here angle is between 0 and 90, and this here is also between 0 and 90 degrees. Show that the area of the trapezium is given by the function a equals blah. So let's have a look at our formula sheet. Unless you guys know that trapezium rule off the top of your head, but I definitely don't. All right, so area of trapezium, a equals half outside of a plus b times h. So first step is going to be to jot that down. A equals half a plus b h. For a little trapezium, so area of trapezium equals half outside of a plus b times h. So here h is going to be this height here, so it's actually going to be y in this case. A will be this top length here too, and b should be this bottom length here. So the bottom length, we've written our formula, let's define our variables in the context of this question specifically. So we got a equals 2 meters. I'm not going to write the units. A equals 2, h equals y, and b is this span along here. So that's going to be x plus 2 meters plus another x. So it'll be 2x plus 2. Right, so we can't quite work with this yet. We can't just sub those in. We need to actually define y and x. So the question should tell us this. If we consider this as a right angle triangle, which it is, we can actually use trig ratios to represent the sides y and x. So let's find the side y. So using this as our theta, and this is our right angle triangle, trig ratios tell us that this is opposite the angle, and we'll use the hypotenuse here. So the trig ratio for opposite and hypotenuse is sine. So we can write that sine theta, I might write this in, get some color coordination here. Sine theta is equal to opposite over hypotenuse is equal to y over 2. And then if we rearrange this, we can times 2 to both sides, and we should end up with y equals 2 sine theta. All right, so let's use trig ratios again to find x. So x is running along the base, so that's adjacent to the angle theta, and we'll use the hypotenuse again. So the trig ratio for adjacent side and hypotenuse is cos. All right, so cos theta equals adjacent over hypotenuse equals x over 2. And we rearrange that, multiply both sides by 2, and we get x equals 2 cos theta. And so now we've got definitions for y and x. Let's plug them back into here. So we can update our variables. A still equal to 2, h equals 2 sine theta, and b equals 2, so then 2 cos theta plus 2. We'll tidy this up a bit. So 2 times 2 cos theta is just 4 cos theta plus 2. So now let's sub these back into our original formula for a trapezium. So area of trapezium equals half A is 2 plus B is 4 cos theta plus 2. This is quite a mess. Times H is 2 sine theta. So now we just got to clean this up. So straight away, a half times 2 is 1. So this can cancel out. Then we'll have 2 plus 2 inside the brackets is 4 plus 4 cos theta times sine theta. And so last step here should be 4 times sine theta plus 4 cos theta sine theta. So we'll have 4 sine theta plus 4 cos theta sine theta. And let's compare that to what they gave us. So show that the area is given by the function a equals 4 sine theta cos theta plus 4 sine theta. So this is addition. Order doesn't matter, but we can write it as 4 sine theta cos theta plus 4 sine theta. Order doesn't matter for this stuff. So that's part A done. Determine the value of theta that will maximize the area of the window. So maximization problems at this level should be done by taking a derivative and letting that equal to 0. So that'll give you a stationary point, and then we can show that that is a maximum and not a minimum stationary point. So let's take the derivative of this function here and set it equal to 0 and see what we got. But for intuition, before we do that, I might just we'll see if we can graph it quickly on Desma. So 4 sine x cos x plus 4 sine x might give us some intuition. So this is the area function. It is a trigonometry function, which is why it is repeating over and over again. What else we got? So if this is the function of the area, we can clearly see visually that pi on 3 is the x coordinate for the maximum area, and the maximum area is equal to 5.196. So if we take the derivative and set it equal to 0, we should be trying to hunt down this x equals pi on 3 coordinate. this is what we don't want. We don't want 5 pi on 3, because that would be a minimum. Right? So we need to find the derivative, set it equal to 0, and hunt down x equals pi on 3. I'm not sure what graphics calculators most of you guys use, but they should be able to graph trig functions, hopefully. And that might give you a little bit of intuition when you're doing these questions for values that you need to hunt for. And that should help in the exam. So let's do the derivative of this. So 4 sine theta cos theta plus 4 sine theta. We can just split this up because it's just addition. So we know straight away the derivative of 4 sine theta should be 4 cos theta. 4 sine theta times cos theta. You could use a product rule here, but with this type of question, I assume you've been working on trig identities. And the derivative of sine theta cos theta should be cos, it's a double angle formula, so it should be 4 cos 2 theta double angle plus 4 cos theta. Let me just check my trig identities to make sure I haven't made a mistake. Yep, that's all good. And then we're going to set the derivative equal to 0. So I'm assuming with this type of question you guys have done trig identities to know that the derivative of sine theta cos theta equals cos 2 theta. Your calculator, if it's a graphics one, should be able to take derivatives for you as well. So you could do it on there, but basically all we needed to do was a derivative of this function and then set it equal to 0. So let's see where that gets us. 4 cos 2 theta plus 4 cos theta. Let's factor a 4 out the front. Might clean things up a bit. Right, so we just took the 4 out the front. Divide both sides by 4. So this would cancel out, and 0 divided by 4 is still 0. So we end up with 0 equals cos 2 theta plus cos theta. And then we can take this to the other side. So negative cos theta equals cos 2 theta. Right, so at this point, how are we going to get exact values for theta? Right, so we need a value for theta that satisfies this equation. So we need value for theta where negative cos theta would be equal to cos 2 theta. So let's refer to the old faithful unit circle. I'll just pull one up online and have a look at the values. Bear with me. Okay, so this is our unit circle. We need a value for theta. So, 0, pi on 6, pi on 4, pi on 3, blah, blah, blah. So that negative cos theta is equal to cos 2 theta. Right? So let's have a look at some different values here. So just as an example, let's pretend theta was equal to 0, even though I suspect that's not going to give us the correct answer. So let's pretend theta was equal to 0. What would that look like? It would look like this. I'll do it in red. Negative cos 0 equal to cos 2 times 0 is 0. So does negative cos 0 equal cos 0? Let's have a look at our unit circle. So cos 0 is 1, and negative cos 0 would be -1, right? So just to show you the working out for that, cos 0 is equal to 1. So we would have cos 0, 1, -1 equals to cos 0, 1. We can clearly see that this is not equal. So that means that theta equals 0 is not our solution to this expression. So let's look at the unit circle and try to find one that's more applicable. So if theta was pi on 6, our cos value would be √3 on 2. So our expression would be negative √3 on 2. And that has to be equal to cos 2 theta. So cos 2 pi on 3 would be -½ So -3 on 2 is not equal to -½ so pi on 6 is not our answer. Let's try pi on 4. So the cos value, or the x-coordinate for pi on 4, is √2 on 2. So if we subbed that into our formula, we would have negative √2 on 2, and we have to test whether that is equal. Let me just draw this in. Is that equal to cos 2 theta? So is negative √2 on 2 equal to cos 2 theta would be cos pi on 2, which is 0. So -2 on 2 is not equal to 0. So let's try pi on 3. So if we subbed pi on 3 into our expression, we should have something like this. Negative cos pi on 3 equals cos, so 2 pi on 3. Right? So then we look at our unit circle for exact values. Cos pi on 3 is equal to ½ and cos 2 pi on 3 is -½ So if we go and sub that in, cos pi on 3 was equal to ½ so -½ and cos 2 pi on 3 was equal to -½ So we can see that these are equal, so therefore theta equals pi on 3, and that should give us our max values. The other thing we had to check, if you remember at the beginning of the equation, at the question, theta was between 0 and pi on 2, and pi on 3 obviously satisfies this constraint as well, which was the other constraint provided in the question. So the theta that gives maximum angle theta of maximum area for max area is equal to pi on 3. Right, so we just found that using optimization. So derivative, set it equal to 0, and then we used the unit circle to find the exact values, and theta was equal to pi on 3. And that's it for part B. And again, if we go and look at the Desmos, we can see that pi on 3 is in fact the solution that will maximize our area. We could even graph the derivative for cos 2 theta plus 4 cos theta. So 4 cos 2x plus 4 cos x. So this is our derivative, and we can see that the solution we found is pi on 3. Right? So again, pi on 3 provides this peak here, which is the maximum area. The reason they provide this constraint here, that theta must be between 0 and pi on 2, is so that we don't end up finding something over here, 7 pi on 3, 13 pi, 19 pi, because these are all valid solutions as well that will provide maximum area, but they're actually all the same angle when you convert it down. So luckily they've been kind enough to give us that theta must be between 0 and pi on 2, which just restricts us to finding this first maximum in the trig function. Right, so that's nice of them. But that question is all done. So let's see what else we got. Question 8. Paper 2, question 1. Oh yeah, this one, this could be fun. Looks like another geometry question. 2 mobile phone towers in range of you are located 2 kilometers apart along a straight road that runs east to west. Your location is north of the road. Based on the signal strength, you have determined that you are 1.5 k's from tower 1 and 800 meters from tower 2. Determine your direction relative to tower 1 and the time it would take you to get to the road if you walked due south at 5 kilometers per hour. So what we are looking at, if I just get my pen, this is question B. We'll need to find that, and question A is finding this angle in there. Right, so we got a non-right angle triangle. Let's have a look at the, oh no, I was on this wrong screen. This is question 1 here for paper 2. Mobile phone towers, blah, blah, blah. Non-right angle triangle. Determine your direction relative to tower 1 is just this angle here. Tower 1 back to your location. And part B, the time it would take to get to the road if you walk due south, so our location straight south, we'll need to find the length of this here. Non-right angle triangle, so we will find a formula from our sheet that gets provided for a non-right angle triangle to find some information. Okay, here we go. Trigonometry. Alright, so we can't use, let's use, we'll use cosine rule, I think. Either the cosine rule or the sine rule should help us out here. So we are trying to find an angle, but we only know, what do we know? We only know we know all 3 sides, and we need an angle. So that should tell us that we're going to use the cosine rule, I believe. All 3 sides, C, A, and B. A and B will enclose the angle C. So I'll just label that now for you. So this can be angle C. Means this is, whoa. This is side C. This is angle C. A and B is arbitrary. We can just write that in as whatever. So this is angle A. Sorry. This would be angle B. This would be angle A. And this would be angle C. Right? So 3 sides and 1 angle tells us that we should be using the cosine rule for a non-right angle triangle. So, since I definitely don't remember that, c squared equals a squared plus b squared minus 2ab cos c. C squared equals a squared plus b squared minus 2ab cos C. So in our case, that's going to be this angle theta here. So let's go ahead and sub in our values. So we should have, let's convert the units. So 800 meters is 0.8 of a kilometer. Right, so 0.8 squared should be equal to 1.5 squared plus 2 squared minus 2 times 1.5 times 2 cos theta, which we are trying to find. Important thing to note when using the cosine rule is that this angle theta is enclosed by the sides A and B. Right, so it's very important that A and B can be swapped, but it's very important that A and B enclose this angle theta. Alright, so now let's just do some arithmetic. So 0.8 squared should be 0.64. I better double check that. Yep. 1.5 squared will be 2.25 plus 2 squared is 4. 1.5 times 2 is 3 times negative 2 is negative 6 cos theta. So we'll just tidy this up. So this will be 6.25 and we'll minus it across. So 0.64 minus 6.25 will be negative 5.61. So we put these two together and then subtract them over to the left-hand side. We get left with this. And now last thing we can just divide by negative 6. So negative 5.61 divided by negative 6. I'll just use my calculator. 0.935 equals cos theta. And here, if we remember how to do year 9 or 10 trigonometry, inverse cos of that should give us theta, and we'll use a calculator for that. So we have cos 0.935 gives theta equals 20.77. So make sure your calculator is set to degrees for that one, otherwise you're not going to get a very good answer. I'm just going to double check that that's correct. Oh, that's weird. That's negative 0.935. 17.64. Yeah, so I got 20.77 degrees for that one. So this angle up here is 20.77 degrees. What can we see? I don't know if they want true bearings. Using the Z rule, we know that this is also theta. If there doesn't, I haven't seen any other bearing questions so far, so I wouldn't think they want you to measure it from 360, but if they did, it would just be, you'd have to draw on your little compass here, 90, 180, and then you add on this last little bit would be 90 minus the 20. So it'd be 90 plus 70 degrees would give you the angle in bearings. So it would be roughly 90 plus 90 plus 70. It would be roughly 250 degrees from your location. But depends if you've been doing bearings or not, whether you actually need to provide that kind of answer or whether you just need to put in theta there. So that's you guys should know the context for that. I'm not sure if you've been studying bearings. So let's look at part B, the time it would take you to get to the road if you walk due south. So that's just finding this here, this ray coming down here. So here we can imagine a right angle triangle. We know this angle, so let's use that to our advantage. all we have to find is this side. So for right angle triangle, if we need to find a side, we can just use our year 9 or year 10 trig. So that'll be opposite the angle, and let's use adjacent. So the trig ratio for opposite and adjacent is tan. So we can write tan theta is 20, roughly 0.77, is equal to opposite over adjacent. So x over adjacent side is 2. So therefore 2 times tan 20 is equal to x. And we'll just go ahead and plug that in on the calculator. And we get x equals 0.758 kilometers. Right. The time it would take, so if we are walking at 5 k's an hour, so speed equals distance over time. 5 k's an hour equals 0.758 k's over time. Let's times both sides by t and divide both sides by 5. So they just swap places. And we'll use our calculator to get t equals 0.1517 hours, I think. So that should be 9 minutes approximately to walk that distance. And that sounds about right. If we can walk 5 k's an hour, and that's, about just over 2/3 of a k, it shouldn't take very long. Let me just double check that that's right. Yeah, that's roughly 9 minutes. Up to you guys how you want to present that solution, whether you want to keep it as decimal, or if you want to convert it to minutes, you just multiply by 60 to get from decimal to that. Because this here is in hours. Okay, so that's part B done as well. What else do we have? I guess there's quite a bit to do. We'll clear that and get the next question in. Just gonna go grab a drink of water. So I'll be back in a second. going to finish off this muesli bar. One thing I do recommend when you're sitting exams, I'm not sure how long you guys get for this one, but I definitely recommend taking a break at some point. If it's more than an hour, if it's like 2 hours or 3 hours, you should be taking about a break every hour to go and, just get up, walk around, splash your face with water, something like that, just to, wake your brain up, because the longer you sit down, the slower your brain goes and the dumber you get. So that's something I did through all my uni exams, because they used to go for about 3 hours and maybe 10-20 minutes perusal time at the beginning. So you don't want to be sitting down for 3 hours and trying to do hard maths. So definitely recommend getting up every hour or so, just have a quick walk, say you need to go to the bathroom or get a drink. Just gets the brain going again. Alright, so it looks like another geometry question here with a non-right angle triangle. A homeowner is building a triangular garden bed as shown in the diagram below. A layer of soil 15 centimeters deep is needed to fill the garden bed. Determine the volume of soil that is needed. So to find volume, that's a three-dimensional thing. One of our techniques that you would have learnt so far is find the area or cross-sectional area of the two-dimensional shape and then multiply it by that depth or height, right? So to approach this to find the volume, if we find the area of this triangle and multiply it by that 15 centimeters, then we should get the volume of soil that is needed. And there'll be some unit conversion here. We'll have to convert this to meters if we want to present the volume in cubic meters, rather than converting these two to centimeters. So let's, either or, it doesn't really matter. Let's find the area of this. So to find the area of a non-right angle triangle, we can use, what can we use? This won't be helpful. You guys must have done Heron's rule at some point, right? Heron's formula. Heron's formula we can use to find the area of a non-right angle triangle. That's what I normally use. Maybe you guys will be familiar with something else. I just don't think half base height will be used here because we won't really have the height. So I'm surprised Heron's formula is not on here. Well, it is the best option here. I don't think this will be useful. But let's see how we go when we get to it. Let's just get started. So to use any of those rules, we're just going to need to find out the information. So what I mean by information is, we got two sides here. Let's find the length of this side. We got one angle. Let's find the other angles, and then we'll see which formula we could actually use. Right. So if we have two sides, one angle, note that it's not the enclosing sides. So we're probably not going to use cosine rule, and we couldn't anyway because we don't know the third side. So let's use sine rule. So I'll just double check. what sine rule actually is. Trigonometry. A over sine A equals B over sine B. So A over sine A equals B over sine B equals C over sine C. So we have angle B and here, and we have side C. So let's find, we'll call this theta 1. Let's find theta 1. And actually, another thing in the exams, it's not a bad idea to explain what you're doing with the little title up here. I used to do that in all my exams. So find theta 1, we'll use the sine rule. So we can write that B over sine B equals C over sine C. So that's just straight from our formula sheet. And then let's sum in values. So B is equal to 8 over sine 125 equals C is 3.5 over sine, we obviously don't know the angle C because that's what we're trying to find. So now we just need to rearrange it. So we need to isolate and get sine C by itself. So I'm thinking we times it across and then we get rid of all the other stuff. So sine C 8 over sine 125 equals 3.5. And then we can just get rid of this stuff. So we'll times this to the other side, sine 125. We'll divide 8 to the other side. So we should get left with sine C equals 3.5 times sine 125. And divide 8 across. Right, so sine C equals, use the calculator, let's put 3.5 times sine 125, make sure it's set to degrees, not radians, and we get 0.358, and then just basic trig, we'll use the inverse function. So sine to the power of -1 of 0.358 should give us the angle C. So that's another calculator. So 0.358 inverse sine C equals 21 degrees. Right. So theta 1 equals 21 degrees. So now here, this we can write as 21 degrees. Okay, so internal angles of a triangle add up to 180. So from that, we can say that 180 must be equal to angle A plus angle B plus C. So 180 equals A plus 125 plus 21. So A should be equal to, what's that, 146, 180 should be 34. I'll just double check that. Minus 125 minus 21. Yep. So A is approximately 34 degrees. And that's just from knowing that these should all add up to 180. And you guys should be familiar with that. So now we can use sine rule again, actually, to find, because it's easier to use than cosine rule, to find BC, or side A, rather. So let's just say find A. Right, so using the sine rule, A over sine A equals b over sine b. Sub in values here. So a over sine 34, because a is 34 degrees. B was 8. Sine b was sine 125. We just need to solve for a, so we'll just multiply both sides by sine 34. And we get left with 8 equals 8 times sine 34 over sine 125. Right, so a, let's use calculator. 8 times sine 34. Make sure, again, that you're in degrees for this stuff. A should be equal to 5.46 meters. Okay. 5.46 meters. Right, so we've got all our angles, all our things, so all our sides, so we can find whatever we want really, but we need to find the area. Now, Heron's formula wasn't listed on your formula sheet, which is... Oh, okay, no, we can use this one. Area equals half BC sine A. Area equals half BC sine A. That should be for non-right angled. What do we got? Oops. I just haven't used this in years. I want to double check that. Yeah, non-right angle triangle. So, where are we? Area equals half BC sine A. And that should be a bit easier to use than Heron's formula. I'm just going to clear all this stuff. Don't need it. Area equals half BC sine A. Oops. Yeah, and my general approach for these types of trigonometry questions is find all the information. So find all the angles and sides, and then you'll have no trouble doing the second half, which is just applying a formula. Just go to the formula sheet and find the relevant one, and then it's just a matter of substitution and some basic algebra. So we've got all our values for this now. So we'll just sub them in. So B will be 8 still. C is 5.46. And I also recommend using brackets. Make this a habit for your substitution if you haven't already. It's just a really good way to keep everything clean when the expressions get a bit more complicated. Sine 34. Right. So that's just 4 times 5.46 is 21.74. Let's double check that. Oh, 21.84, sorry. That's why we use a calculator. 21.84 times sine 34. Right, so area equals 12.2127. So you can obviously round that, but when we go to do our actual calculation, I prefer to use the full response that my calculator gave for when we do volume, just more accurate. So to find volume, we can use the area of a cross section, so this times the height, right? So the area of the cross section was this here, 12.21, times the height of 15 centimeters, which is 0.15 meters. But I'm not actually going to write meters. And then we will use our calculator. So I'm going to use that full response that I got earlier to make sure it's accurate. Times 0.15, volume is 1.83 meters cubed. So that should be the volume of soil that is needed. So in an exam, volume of soil needed equals 1.83 meters cubed. Should be sufficient for that question. So let's clear that. Okay, so right, so we got some statistics here. Assume that 45% of people watch more than an hour of Facebook or YouTube videos a week. Using the normal approximation, determine the approximate probability that in a randomly selected sample size of 400, more than 50% of people have watched. So normal approximation is important. Whoops, that's not an underline. That tells us what kind of distribution we might use. Normal approximation. Randomly selected. Okay, so sample size tells us that it's a sample population or sample proportion type question. And we need to define the probability that more than 50% of people have watched more than an hour of Facebook or YouTube videos in a week. So let's just jot down a couple of things. So this is like, for the very first question we did, average for the population was 45%, or 0.45, and they watched more than an hour a week. Using the normal approximation, so sample size, so n sample is 400. Find the probability that more than 50% of people, more than 0.5, have watched more than an hour of Facebook or YouTube videos in a week. Alright, so for these questions, I think there's a couple formula that we need to use. So let's look at the formula sheet. Go to our statistics section. We've been given these for sample proportion, so mean is P. We've been provided that in the question. So straight away, since we have P and N, we can find the standard deviation. And once we have the standard deviation, we can actually use our Z scores with the Z tables to find the probability, knowing that this is a normal distribution, right? So that will look something like, I'll write down the formula here. So the first thing we'll do is find sigma, which is equal to square root P outside of 1 minus P, and this is PS, by the way, not PP, over N, right? So now we just sub in our values. 0.5, 1 minus 0.5 is also 0.5, over N is 400. Let me just check I haven't made a mistake here. What was our formula? P, 1 minus P over N. Let's double check that. Standard deviation proportion sample. Yep, sample proportion times 1 minus sample proportion over sample size. So that is all good. That's a bracket. Right, so plug that in on the calculator and we get 0.025. The standard deviation for the sample is 0.025. So now that we have that, we can use this formula here. So Z, and this is where we do our normalization. So Z is equal to X minus mu over standard deviation. So in this case, X is what we want. So we want 50%, and mu is the average. So on average, in this question, 45% of people watched it. And then we'll divide it by our sigma s, 0.025. So Z equals X is our target, so 50%, minus mu, which is our mean, is 0.45, because that's our population average. And then we'll divide it by sigma. So Z should be equal to 0.5. This is just put it on the calculator. Z equals 2. Right, so at this point, we'll use our Z tables, which they, I assume, have to provide in the exams. Here we are. Z tables, Z equals 2, 0.9772, right, is our answer. 0.9772. So using table we get Z score of 0.9772. Let's see. More than 50% of people. Right, so when we're using a normal distribution, I'll just draw a little graph here. We basically have this situation. So bell curve, and what we wanted was, say, about here. So let's say this is 50% of the population using Facebook for more than an hour. This probability that we just found using the Z tables is here, right? So that's going from 0% to 50%, and the question asks for find that more than 50% of people have watched, so we actually need this over here. So if I can remember stats correctly, this whole thing should add to 1, so if we do 1 minus this red probability, we should be left with the complement, which is what the question's asking for. More than 50% of people have watched more than an hour of Facebook or YouTube videos a week. So we should just be doing, if our probability is 0.9772, 1 minus 0.9772, or whatever we got for our Z score, I'm not sure if you guys are using the tables, should equal 0.0228 is the probability that more than 50% of people will be watching both. That sounds about right. I'll just see if there's anything else that I don't made a mistake somewhere, but seems right to me. Um, 2 point. Yeah, it should be in that ballpark. I'm not sure if you guys are using Z tables or not, but process for this question should be pretty similar. Find sigma, and then normalize it because it's normal approximation, and then either use the tables or do the direct calculation and find the probability that more than 50% of people have watched. So the only interesting thing, I guess, in this question was making sure when we use our Z tables, we're finding the probability from left to right of a point. So when we do 1 minus, that should give us the complement of that. Let's see. All right, let's have a look at the next question. So, question 4. A multiple choice test consists of 8 questions. Each question has 4 possible answers, so this looks binomial. Only one of the answers is correct. For each question, Tom randomly selects one of the 4 answers. Determine the probability that Tom answers exactly 3 questions correctly. So this is definitely binomial. So whenever we see this wording here, so he randomly selects one of 4. So we've got a random probability there. And then whenever we see determine blah gets exactly blah, right? So we have 1 of 4 as our outcomes, and we get exactly 3 correct. That should tell you that it's going to be binomial. Right, so let's have a look at what we have on the formula sheet for binomial. That's it. This one here. Probability x, which is our desired outcome, equals 3, is equal to n choose r times p to the r, 1 minus p, blah, blah, blah. So let's write down that formula. And see if we can remember that in one go. Probability x equals r equals n choose r. Okay, no, I can't remember that. N choose r times p to the r times, outside of 1 minus p n to the power of n minus r. Right? So in this example, n should be 8 because there's 8 questions, and then r should be 3 because that's how many we want right, and the probability of getting a single event or a single question right is 1 out of 4, so 25%. So n equals 8, number of questions. R is our desired outcome, so we want exactly 3 questions correct. And P is the probability of our desired outcome in any given event. So in any given question, we have a 1 in 4 chance. So we assume that the probability is equal to 1 in 4 or 0.25, 25%, whichever. All right, so then if we just go and sub these in, P is a quarter, R is 3, 1 minus a quarter, 8 minus 3, and let's tidy it up a bit. Whoops, 8, 3, a quarter cubed. 1 minus a quarter is 3 quarters. 8 minus 3 is 5. And then we can just pop it in on the calculator. So, where are we? Right. So you guys should hopefully be familiar with how to do binomial calculations on your calculator, but we just have to use the correct buttons and choose R. So N is 8, R is 3, and then we times by a quarter cubed times by 3/4 to the power of 5, and we get 0.2076 blah blah blah. So let's just 0.207 should be good enough. Alright, blah blah blah. And that's it. That's the probability that he gets exactly 3 correct. So this is straightforward. Binomial. Write down the variables, sub them into the formula from the sheet, get your answer. You just got to know how to use your calculator there. Depends which one you have. Okay, next question. In the shot put at a school athletics carnival, it is determined that the distance is continuous variable with PDF. So they've given us the probability density function of PDF, and it's piecewise, so defined from 0 between x, where x is between 0 and 12. We have to show that the mean distance thrown is 4.5 meters. So if we remember our steps, this is an expected value question. So we just use the formula from the sheet. For part A. So I believe, I will double check that, but I believe it's expected value equals mu equals the interval. In this case, it'll be 12 to 0 of x times px with respect to x. So let's just double check that. Don't want to make a mistake if we don't need to. Oh yeah, I just use Wolfram Alpha for this, for the previous question to calculate the probability. So oh yeah, where are we? Expected value for a continuous random variable is this. So integral, take it from negative to positive infinity of x times our probability density function with respect to x. So this is correct. We'll take it from 0 to 12 because that's where our function's defined. It's 0 otherwise, and then x times px. So let's get this started here. 0, 12, x, and then we'll put in our PDF here. So 1152. Yeah, so let's just clean this up. Let's expand out these brackets first, and then we'll keep going. So 0, 12. So you guys should know how to do this. 144 over 1152 is I think it's an 8th. I'll check that on my calculator. Yep. So 144 over 152 is an 8th, and then this times negative x squared. Yeah, and now we can multiply in x. So x on 8, this thing here, x on 8 minus x cubed on 1152 dx. And this should be relatively straightforward integral. So x squared, raise the power divided by the new power, so x squared on 16 minus x 4 on 4,608. Yeah, 4,608. Good guessing. Between 12 and 0. That sounds right. So now we just sub in, so top value first. 12 squared is 144 over 16 minus, I can't do that in my head, 4608 minus, so here we'll sub in 0, so 0 squared over 16 is 0, 0 to the power of 4 is, so that whole thing's just going to be 0. Which works out quite nicely for us. So now we'll just use calculator. Right, so this whole thing evaluates to 4.5, which is perfect. Yeah, that was pretty straightforward. Just take the integral between 12 and 0, make sure we copy down this correctly. So that's part A done. Part B, determine the standard deviation for the throw. So that again should just be formula sheet. So if we know the relationship between standard deviation and variance, that's pretty straightforward. So we can use this one here to find variance, and then we'll just exploit the fact that we know that variance equals sigma squared. I'll double check that, but I'm pretty sure that's it. So let's find the variance first, which is x minus mu squared. Let me go ahead and rub all this stuff out. X minus mu squared x minus mu all squared times px dx. So variance of x equals integral between negative positive infinity x minus mu squared times px with respect to x. Right, so we have mu. Our boundaries are going to be between 0 and 12 because that's where our function's defined. That's a continuous theme throughout that we'll be evaluating. These are called piecewise functions. Hopefully you guys know that. So we make sure we use the correct bounds instead of negative and positive infinity. Because our function's obviously not defined outside of here. We'll sub in mu. We know from part A that it's 4.5, but even if you couldn't do part A on the exam, since they've given it to you here, you should just sub in 4.5 anyway. So now let's write in our specific integral. X minus 4.5 squared times px. So if you remember from last time, px can be written a little bit more cleanly as 1/8 minus x squared on 1152. That's just going to be a time saver. So we'll clean this up before we actually do any integration. So let's expand this. We'll do x squared. I should do it the long way just so you guys can see. If you've done enough of these, you don't have to do it this long way, but it's not a bad idea to show you anyway. Alright, so first outside, inside, last, we're going to use FOIL to explain these. So first is x times x squared, negative 4.5x, negative 4.5x, negative 9x. Last 4.5 squared is why couldn't I do that? 20.25. Right. And then what else could we do? Tidy it up. We can expand this in. So you just multiply each term with the other term. So we'll do the x squared term first. It'll be x squared on 8 minus x to the 4 on 1152. So we've done this one now. We'll do negative 9x. So negative 9x on 8 plus negative, plus 9x cubed on 1152. So we've done that. One more term to go. Plus 20.25 on 8 minus 20.25 x squared on 1152. That's a handful. I'm thinking, yeah, that's fine. This should be manageable. It's just take your time with doing that expansion there. All right, so now we can take our integral. So x cubed on 24 minus x to the 5 on 5,760. I will double check that times. Yep, that's all good. Minus 9x squared on 16 plus 9x4 on 4,608 plus 20.25x on 8 plus, minus 20.25x cubed on 3,456. Yeah, that's right. Between 12 and 0. So then I will do this by hand. If you should really just plug this into your graphics calculator should be able to do this really easily, but we'll go through it by hand. So we'll be subbing in 12, the top bound first. Very time consuming though. And this is also where people tend to make mistakes. Well, it's good practice though. And then we'll minus the 0 substitution. So that's going to be 0, that's going to be 0, that's going to be 0. It's all going to be 0. So now we can type it in on the calculator. So 12 cubed over 24 minus 12 to the 5 over 5760 minus 9 times 12 squared over 12 plus 9 times 12 to the 4 over 4608 plus 20.25 times 12 over 8 minus last one 20.25 times 12 to the 3 over 3456. That's not good. Negative value means we've made a mistake somewhere, probably on the calculator, typing this in. I don't believe we should have negative standard deviation. Let me have a look at what I typed on the calculator. Let's maybe you don't even have to do any of that. Maybe you don't have to do any of this, and you can just type in the integral, because this is the calculator section. So you could have just evaluated the integral from the very beginning, x minus 4.5 squared times whatever we had, the px dx, the px part. Yeah, you can just evaluate this, because this is the calculator section. You should just be able to type this in on your graphics calculator, and it spits out. What do we got here? .55. So I actually wouldn't even bother about this by hand method. And obviously I made a mistake typing it in on my calculator and got a negative value, which is a big red flag because we shouldn't have negative areas. So it would have just been when I was typing it on my calculator, I would have missed the negative sign somewhere. I trust the by hand stuff more than I trust my ability to type things in on a calculator. But yeah, so this integral, you should just be typing it in on a calculator. I was thinking that they won't expect you to do all this by hand anyway. It's a bit messy and very time consuming, and I think at this level, they just want you to type it in on the calculator. So 8.55 is a solution. So variance of our variable x is equal to 8.55. And now let's just check the relationship between variance and standard deviation. And we can see that variance is sigma squared. All right, so where are we? If variance, oh, there we are. if variance equals sigma squared, and we wanted sigma, variance equals sigma squared, and we want sigma, then square root variance should equal sigma. So sigma equals square root 8.55, which means in this case sigma equals 2.924. So that should be our answer for part B. Sigma equals standard deviation, which is 2.944 per throw. So now we can rub this all out. Yeah, definitely didn't need to do that by hand. I think that's like you guys would have seen that and maybe realized, oh, okay, this we can just plug straight in on the calculator, but I'm not the one sitting in the exam, so I don't always know what's expected to be done by hand and what can just be chucked in on the calculator. You guys should know that, having done textbook questions and working class. You'll have a better idea of what's expected. That's a part C. Determine probability that determine the probability that the throw is greater than 2, given that this is conditional probability here, given that x is less than or equal to 4. Right, so the probability that our throw is greater than or equal to 2, given that it's less than or equal to 4. So here, I believe we can use this. You guys haven't learnt Bayesian theory, but I think they've chucked it on the formula sheet. I'm not sure how this here. Let's use this definition here, and maybe we'll use this one here to see what happens before we actually start this question. So what do we got? Probability of, by definition, probability of A given B is equal to, and this is where we use this here, is equal to A and B over B. Right, so the probability of A given B is equal to the probability of A and B over the probability of B. And now we can use another definition, probability of independent events. So probability of A and B is probability of A times B. All right, so that changes this top bit to probability A times probability of B over probability of B. All right, so we can cancel those out. So this question can be rewritten as just probability of x is greater than 2, event A. There should be some intuition to that, because greater than or equal to 2, I think given this distribution probability density function, the way it works when we're doing our bell curves, bollocks. The way it works when we're doing our bell curves, we get our bell curve, and we shade the probability up to a given event. If we're looking for something greater than or equal to 2, given that it's less than 4, that should be quite obvious. But let's shade in what we're actually trying to find here. It should be something like this. Maybe here is 2, and here is 4. Right, so we'll find this red area, and we'll find this green area, And what do we need to do? Maybe some subtraction. We need to find this greater than 2, given it's less than 4, will give us this area here. Right, so if we find all the way up to 4, all the way up to 2, and we do the 4 minus the 2, we should get this in between area, which is the throws greater than 2, given that it's less than 4. Should be that blue area there. So P x greater than equal to 2, given that x less than equal to 4 is the blue area we need to find. So let's find, let's get rid of that strike. I'm not sure how necessary this is, but let's find probability x is greater than or equal to 2. Right. 1 second. I'm just going to grab some water. Yeah, so definitely the approach with these questions is, especially with the conditional probability, you want to be drawing that bell curve so that you actually know what you're finding. It's no good just not having a visual for probability questions like this. So anything with a PDF function or bell curve, it's a very good idea to draw the bell curve and shade in what you need to find. So, because finding the individual, probability of x greater than or equal to 2 shouldn't be too hard. But knowing what you have to do and subtract is the most important part, I guess. So let's find the probability x is greater than 2. So this is a PDF function, which means we can just do some integration, I believe. Continuous function. We don't even need the formula sheet. We can just take the integral from 0 to 2 to find the probability that x is greater than 2. We'll do a little trick here. So for this one, our bell curve will look like this. It would look like, let's say that was 2. Greater than 2 is this area over here, right? But we're going to find the area leading up, and then we're going to do 1 minus that area leading up. And that'll give us the complement of the green area. So the probability that x is greater than 2. So we'll just go 2, 0 are our bounds. And we're going to plug in our PDF function here, which is still a handful. So a simplified version was this, I believe. I'll double check that. Yep. Minus x squared, yep. With respect to x, can't forget that. So let's just evaluate that. It'll be x over 8 minus x cubed, minus x cubed on 1152 times 3 is 3, 4, 5, 6, between 2 and 0. And again, like graphics calculators, you can literally just type this top chunk in and you'll get the definite integral straight away. I don't know whether they expect you to do these by hand or not. You know, how much working out do they want? So now we'll sub in 2, our top bound. And then we'll sub in 0, so that whole thing's just going to be 0. So we'll end up with a quarter minus 8 over 3, 4, 5, 6, which is quarter minus 0.24768, blah, blah, blah. So we can just round it 0.245. That's just for simplicity's sake. They'll specify what kind of rounding they want you guys to do on the exam sheet. So that's the probability x is greater than 2. I mean less than 2. So the probability that x is greater than 2 is 1 minus probability x less than 2. So we should have 0.75 roughly for this probability. Now what's this? Right, so this is our first one, and now we'll do the same from 0 to 4. There's actually probably, you could have just done this PDF function from 2 to 4 would give you that area straight away. I've just seen that instead of having to do the minusing, you could just find the area under the curve from the boundaries 2 to 4, because that's the same as doing this. And then so because it's a PDF, a probability density function, and we're just taking integrals, we can save time by just making this bound 2 and 4. But I'll finish off this way. Just I've already started it. I may as well. But in the exam, I would recommend. It would have been nice if I'd seen that earlier. Haven't done these questions in years, so I don't always see the tricks. X on 8 minus x cubed 4, 5, 6. So just subbing in 4 now, so 4 on 8 is half, minus 4 cubed on 3, 4, 5, 6, minus the 0, 1, so it's just going to be 0 there, so equals half minus 4 cubed on 3, 4, 5, 6 is 0.48. Right, so then what we would do is, what do we have to do? We could either do 0.75 minus 0.48, and that would give us the blue area, or we can do the probability, this red line. Let's color code this correctly. So this 0.25 corresponds to this red all the way up to 2, and this 0.48 corresponds to from 0 all the way up to 4. So if we did this minus this, we'll get the blue area. Or we could have done the complement. 0.75 gave us, I don't have another color here, so we'll use the rainbow. This gave us this from here, from 2 to infinity. So we could do 0.75 minus the green would leave us with the blue bit as well. So we have two options there. So let's just do probability x is less than or equal to 2. Color code. Probability x less than or equal to 2 minus probability x less than or equal to 4, because that's how we look at these bell curves, is with less than is wrong order. Probability x less than or equal to 4 minus probability x is less than equal to 2 equals 0.48 minus 0.25, which equals 0.23 or something like that. Roughly 0.23. I've rounded these all early, so that's, what it is. And let's double check if we just took the original integral from 4 to 2 of our PDF, which was, what was it? 1 over 8 minus x squared on 152. 1 over 8. Let's double check that. We'll just pop that on the calculator. Yeah, 0.23. Great. So I wasted a lot of time there. Hopefully you guys saw that before me. Haven't done this in a while, so that's never good. But instead of doing all this and messing around, because it's a continuous probability density function, we can find the area of a given outcome using integrals. And the nice thing about integrals is we can change the boundaries. So if we want the probability between that someone threw, less than 4 but greater than 2, we can just do the integral between 2 and 4. Bam, 0.233, and that's that question done, instead of messing around with all this stuff. So I would recommend this here is all you really need to do. And this is sitting an exam like this, hopefully if you guys have prepared properly, you should have done similar questions. So the little tricks along the way, like shortcuts, should be quite obvious to you. But I don't do this kind of maths often, so often I end up going like a bit of a long-winded way there. We'll get the same answer in the end, but in an exam you got time pressure, so the quicker you can do it, the better. So all those little tricks help. All right, a random sample of recent graduates found that 15 are unemployed. So this is a sample proportion question already, we can see. Calculate confidence interval for the proportion of graduates who fail to find a job. Interpret result. Determine sample size required to achieve a margin of error of 2%. Oh, bother. Determine sample size required to achieve a margin error of 2% for the approximate 90% confidence interval. I have a feeling I messed up the last question by leaving the screen on the wrong screen. Just in case anyone missed, I'll just quickly explain it. We just got to go back to question 5 for a second. So question 5, I'm not sure which part I messed up with the stream, but basically question A showed that the mean distance is thrown 4.5 meters, was an expected value equals mu equals 12, 0 of, this is where we refer to our formula sheet, x times px, so x so it was something like this, 12, 0, x times and then we just solve that integral. You probably just type it in on your calculator to save time, but you can do it by hand. I did. Just type it in on the calculator there. And then part B. Part B, determine standard deviation. We have to remember that variance is equal to standard deviation squared. So if we find variance using our definition, I believe it's variance x equals integral 0, wrong way, 12, 0, x minus mu squared px dx. I'll double check that. Yep. So we just solved that integral between the bounds 0 and 12. Again, that one was definitely, it seemed like you should just pop it on the calculator rather than working out. And then at the end, once we get our value for variance x, we just do some algebra to find sigma rather than sigma squared. So we just have to remember that variance is equal to sigma squared, which is standard deviation. And then the last question, probability of x greater than 2, less than 4. If we think of it as a bell curve, something like this, let's say here is probability x greater than 2, and then here was x greater than 4. What we should do is just take the integral, so we need this blue area here. We take the integral between 4 and 2 of px dx. Oh, 2 of px dx. And that should give us our answer straight away. Again, you can just pop that on the calculator. Yeah, so my mistake for that. This is the first time doing an actual live stream, so next question. Question 6. A random sample of recent graduates. Alright, so n for the sample equals 120. Found that 15 are unemployed. Calculate, so p sample equals 15. Calculate 90% confidence interval. So this is a sample proportion question, so we're going to look for your standard deviation and then z-scores or z-tables, and we'll use this formula here, and then we'll use this formula here, and that should give us our confidence interval. So we'll need a z-table, and then we'll need confidence interval scores. So should be something like this. Commonly used confidence intervals. Okay. So we're doing 90%, so we'll use 1.645 for that, but we'll see when we get there. This is what it looks like, the confidence interval scores. So n equals 120, mean was 15, so let's find standard deviation, p outside of 1 minus p on n, sub in the values. Put that in the calculator. 15 times 14 over 120. Oh, sorry, negative 14. Wait, what? Sorry, what do we got? Found that 15 are unemployed. 1 minus 15. That can't be right. It must be 15 over P would be P is 15 out of 120 equals, I think that's 8. 1/8. 1/8. So here we should have 1/8. 1 minus 1/8 is 7/8, and 120. So pop that on the calculator and we get 0.03 for our standard deviation. Right, so that's the first part. Next part, because what we're working towards is this, I'll show you now, this formula here, confidence interval. So we've just found this part, so now we just need this part here. So in this case, 90% confidence interval is 1.645. Right, so as it stands, for the confidence interval of 90%, Z from the table is 1.645. So using our formula, we have Z we recognize that this whole thing is sigma times sigma. We've already found that. So if we sub in the values, we should have the 1.645 times 0.03. Just type that on the calculator. Right. And that should be our confidence interval. Right. So what we do with this is we say that within 90% confidence, we can say that our average is going to be 1/8 of the sample size. In this case was 120. Plus or minus either side 0.04935. Right? So this here is our confidence interval. We can say it's going to be this much either side of 1/8, and with 90% confidence. So let's see if we've addressed the question. Calculate an approximate, interpret your result. So just it's going to be this much either side of the average within 90% confidence. So determine the sample size required to achieve a margin of error of 2% for the approximate 90% confidence interval. Right, so what they're looking for here, let's say if we were 1/8 was our average, plus minus Z score times P1 minus P over N. We need to find an N such that this whole thing is 2% margin of error for the approximate 90% confidence interval. So let's just sub in what we do know. this z-score was 1.645 for 90% confidence interval. And then we'll have p we know to be 1/8, which means this is 1 minus 1/8 is 7/8, and n is what we're finding. So 1/8 times 7/8 over n. So just working to clean this up. So 1/8 times 7/8 is 7/64. And then we can square this whole thing. 7/64 on n. So what we want to do is just square this whole thing and solve it for n. That's actually really messy. Oops. N 7/64 over n. Just want to square that, rearrange it for n. So what will we end up with? Oh yeah, and I forgot. That's what was confusing. The goal is 2%. So the goal is to have this part of the equation equal to 2%. So let's just isolate that part of the equation. So the goal is to have 1.645 times 7 on 64 all over n equals 2% or 0.02. So now when we square both, let's divide this 1.645 over first. So we'll take that over to the right-hand side by dividing it. So 0.02 divided by 1.645. 0.02. I'll keep this accurately on my calculator, but I'm just going to write that. There are more decimals. But in the exams, it's not worth writing them out. Just make sure when you do the calculation on your calculator, you keep it accurate. So divide that across, then square both sides. Get rid of that square root. So that squared is, I'm just going to write it out as I see it. That's just a really small decimal. And then we can take n to the right-hand side. So this whole thing times by n, and then we can just divide by this thing here. So that'll cancel out. So we'll have on the left-hand side, we would get left with 7 over 64 divided by equals n. You could also, so n equals, let's pop that on the calculator, 7 over 64 divided by that 0.012 squared gives n equals 739.92. So what we say is that to get 2% error margin, something like that, n, which is the sample size, must be equal to approximately 739 or 740. So we'd probably take a sample of 740, roughly, approximately 740. So that's 2%. So to recap for part B, what we need is that this portion of the equation here is equal to a margin of error of about 2% for 90% confidence interval. So we can set this whole thing equal to 2% or 0.02. Sub in Z 1.645 because that's our 90% confidence interval from the table. Sub in P value and solve for N, and that gives our answer. It looks like we got 2 more questions. Okay, so let's clear that one. I think only 2 more. That's pretty good. I'm going quite slow just to make sure I explain everything to a decent extent, but you know, if you don't have to talk, you can get these done quite quickly. Each question shouldn't take more than a couple minutes if you're really proficient. A radar unit is used to measure speed. Speeds are normally distributed 6.7% of the time the cars travel less than 75 k's an hour, while there is a 15.87% chance that they travel greater than 100 k's an hour. So I'm just going to draw a bell curve for this example. These are just good to get some intuition for what we're doing. Okay, so let's call this, so 6.7% of the time, 75 k's an hour. So that's 6.7%. I should actually 6.7, and they're going 75 k's an hour. And then on the other side, there's a 15.8% chance that they're in this section. So maybe actually, while there is a 15.87% chance that cars travel greater than 100 kilometers per hour. So if we had a mark of, 100 k's an hour, let's just say that was here. This 15.87% chance represents greater than 100 k's an hour. So determine the mean and standard deviation for the speed of cars in general. So I think this could actually be an interesting one. We'll have to do some simultaneous equations, but I think what we're aiming for, I think this is what we'll be using. And we'll use this to find mu and standard deviation. Subbing in the examples from the 2 scenarios we've been provided. So let's say let's look at the first example. I'll do that in red. So in the first example, our probability of being that was 6.7%. Right, so 6.7%. And what was that equal to? One second. Was equal to x, so 75 minus mu on sigma. And then over here in the green we can do the 15.87% chance was equal to 100. Right, so I think because we've already been given the probabilities, we can just sub these straight in. I don't think we actually have to find the z-scores using the table. That'll become really obvious later on if we end up with some bad numbers, but that should make sense. They've already given us the probability, so I don't think we have to use Z tables. But let's just see how that goes. So we got two equations here and two unknowns, so we can use simultaneous equations to solve these. I'm just going to grab some water. What's the question again? Determine the mean and standard deviation of the curves. The speeds are normally distributed 6.7% of the time here, 15.87% of the time here. Right, so if we do have to use the Z tables, the only thing that's going to change is this value here. So let's just work with this and see if we get a reasonable answer. If not, then that means these answers, we can't straight away use the this percentage, and we'll have to use the Z tables. But I think this should be fine. So let's just hop in and do that. So let's rearrange these so that sigma is the subject. So we would times by sigma to get it to the left, and then we would divide by this to swap. They'll swap places. So should end up with something like this. And then for the green side, we should have. Let's call that sigma 2. We'll call this sigma 1. Equals 100 minus mu over 0.1587. In which case, so now that these are both sigma is the subject in both of them, we can let them equal each other and solve them simultaneously. So let's go let them equal each other. So 75 minus mu over this should be equal to 100 minus mu. And the reason we can do this is because the standard deviation shouldn't change as long as we're within, as long as both sets of data are within the same question and the same distribution. So that's how we can let them equal each other. So now we can solve this for mu. So let's just times out these denominators. So we should have 75 minus mu times out this denominator. And then we'll times out the other one as well. Right, so all I've done is times both sides by the denominators. And then we'll times that in. Third calculator for this. 75 times this was 11.9 minus, oh actually, and then the other bit, 0.067 times 100, 6.7. Mu. It's about mu. So then let's collect the numbers on both sides. So let's minus over this 6.7. So 11.9025 minus 6.7 gives 5.2025 equals, and now let's add these mu's together. So negative 0.067 plus 0.1587 gives this many mu, and then we'll divide both sides by that 0.0917. So 5.2 divided by the 0.0917 gives 56. So this is where we can see whether we were correct with our initial assumption. 6.7% of the time cars travel less than 75 k an hour, 15.87% chance that they're greater than that. And this average speed of 56 k an hour, assuming all these calculations are correct, seems suspiciously low. So let's verify that this initial assumption was correct. You guys probably realized I was making that mistake straight away because you've been doing these kinds of questions. But let's see what that looks like. If we bring up our Z tables, okay, so if we bring up our Z tables, we can see that the normalized 6.7% would be 0.5239 for the Z score, and the other percentage for the Z score. So let's just make sure I don't confuse anyone here. I'm going to rub this out, even though the calculations are the exact same. Don't want to confuse anyone. Okay, so if we find the Z scores, so using tables, so Z1 we'll do in red, Z1 would be using the tables would be 0.5239, I believe. Yeah, and then Z2 in green, again using the tables, would be, we'll have to do, I think we'll have to do a 1 minus here. So this is the probability in green here, but using the tables, we go from left to right. So the complement of that would be 100 minus this, which is 84.23. So we'd find 0.8423 on the Z tables. 0.84 is 0.7995. So Z2 is 0.7995. And then obviously that's what we've just found then was the left to right area leading up. So we'll have to do 1 minus to get this green bit. So 1 minus this should be equal to 0.2005. So these are our new Z scores. So let's redo those equations. So 0.5239 should be equal to x minus mu over sigma. So x is 75 minus mu is unknown over sigma, and over here 0.2005 equals 100 minus mu over sigma. So let's let them equal each other once we've rearranged for sigma as the subject. So I made that mistake again. So Z table is 1 minus, just plugging it into this equation here, the Z scores and x minus mu. And we're going to make sigma the subject and solve for that. So let's go here. What What else can we notice? Right, so make sigma subject. And over here, make sigma subject. That's just pretty straightforward algebra, hopefully. And then we can let them equal each other and just solve simultaneous equations. So hopefully you guys know how to do that, not just doing the elimination method. Shouldn't be too hard here. So same process as we did like 5 minutes ago, but with the correct numbers hopefully. So we times these denominators to both sides. So we would end up with 75 times. I'm just going to take some shortcuts here. 75 minus mu. Yeah, and then multiply that in. So 75 times the 0.2 gives 15.0375 minus 0.2 mu equals, that's going to be 52.39. Whoa. 52.39 minus 0.5239 mu. And then this one we will train the numbers up. So let's just double check something here. May have made a mistake with the negative somewhere, but it shouldn't matter too much. Join the numbers up. So 52.39 minus 15.2. Should have 0.3239 mu equals 37.35. So mu would equal roughly 115, which also seems suspiciously high. So that's not good. But let's see if we can figure out why, because I guess this is a good example of exam troubleshooting. Although I would suspect you wouldn't make these mistakes in the first place if you've been doing similar questions, but I don't have the liberty of sitting in a class doing this stuff, so. So I might have just interpreted the Z tables. I might have just grabbed the wrong values from there. But the process for this question is the same, using this formula, simultaneous equation, find sigma, and then once we have sigma, we could find mu by just subbing into any one of these. We could sub sigma in and find mu, and that'll give us the answer. I'm not going to do this process again. It's not worth the time. I think maybe the only possible, maybe either the mistake was made grabbing them from the tables, or because this sits on the left-hand side of the middle, it's a negative value, so that negative value would just carry on through here, and we'd end up with a slightly different mu. But you guys should be able to figure that out. You probably worked with the Z tables quite a bit by now. So just process for this one is using this equation here, we'll set up a situation where we can do simultaneous solutions to find mu, and then once we have mu, we have sigma by just resubstituting back into our initial equation. And to grab this z-score here, just make sure that you interpret the tables correctly, and if it's a negative value, it needs to be a negative value. If it's not, it's not. Yeah, but that one actually shouldn't be too. It's quite a simple process. You just got to make sure you don't carry an error through like I did. But the process is what's important. So let's look at the last question. Okay. Right, suppose that 80% of all Australian teenagers use a smartphone. If a random sample of 20 is chosen, so I assume this is sample proportion. Probability, sample proportion lies within one standard deviation. So we'll need to find standard deviation. We've got this, and we've got p equals, oh no. So n is 20, p is 0.8. We need to find standard deviation. So, what do we have to do? Let's check or consult our formula sheet. Yeah, so we'll use this here and see what we get out of that. So standard deviation equals root p outside of 1 minus p on n. So in this case, we'll have 0.8 outside of 0.2 on 20, which will be, pop that in the calculator, 0.089. Right, so that is the standard deviation. So we need to find probability that the sample proportion lies within one standard deviation of the population proportion. So if I'm interpreting this correctly, we need to find, so if the average for that is 0.8, we need to find probability that the sample is within this much either side. So 0.8 minus this would give us 0.71. And then 0.8 plus this would give us roughly 0.89. Right, so find probability sample proportion lies between these bounds here. So we just need to find that, the probability that the sample proportion is greater than 0.71 but less than 0.89. So let's just we'll do red probability 0.71. Right, so that's something like this. So let's oh, sorry. Yeah, that's right. Let me just double check. Right, so if we normalize that, so we're going to use the Z tables. Probability is less than 0.71 because that's how we normally do our Z tables, left to right. Which also, that's probably how I made the mistake on the other question. I can go back to it after this. Probability that's less than that is this situation here in the bell curve. So we should have probability z if we've normalized it. I'll write down the equation we're using. Z equals x minus mu over sigma. So z equals x 0.71 minus 0.8 mu, and sigma was 0.089. So probability z is less than or equal to. Check that on the calculator and we should have negative 1.01. So if we use our z tables now, negative 1.01 will just be the negative of this, so 1.01 is 0.8438. So going back to the whiteboard, this from the tables is 0.8438, but because it's negative we have to do 1 minus, so we should end up with 0.1562. So probability for that is the 0.1562, and then we can do second part will be probability like that, less than 0.89. So this is that second situation. So we'll use our formula z equals x minus mu on sigma to normalize it. So z equals, our target is 0.89 minus our average is 0.8, or mean, over 0.089. So punch that in on the calculator and we get a 1.01 probability z less than or equal to 1.01 using the z tables is 0.8438 as well. Alright, 1.01, 0.8438. So back to the whiteboard, this equals 0.8438. So this situation up here, all we have to do now is take the difference between the two. So we have that this is equal to probability z was less than 0.89 minus probability z was less than 0.71, and we should end up with 0.8438 from here minus the 0.1562 gives us 0.68 roughly. Right? So our answer for this one, that the sample proportion lies within that's one deviation either side of the sample proportion is 0.68. Right, so that one's quite long-winded. So process was sigma, locate that because that's one standard deviation. Then we need to set up this probability here. So one standard deviation either side of the population average is either 0.71 if it's below, 0.89 if it's above, and then we just find each one individually using our z-scores, and we end up with this down here, which we can represent as normalized with our z-scores, so we get 0.68 by the end. So determine probability. Yeah, so probability that it's within either side is 0.68. And that should be that. I'm just going to have a look at question 7 again and see if I can check where I made that mistake. Right, so we did the process right for this one, but had a carried error, so I think that was the Z table interpretation. So let's just double check what was going on there. That's our bell curve. And the goal was to just find the mean and standard deviation. And the way we did that was using this formula here, z equals x minus mu over sigma. And we set up a scenario where we could solve it with simultaneous equations because both mu and sigma are unknown. So z1, let's just double check that we're doing that correctly. Yes, so Z1 should be 0.5239, but because it's left of 0, I think it's going to be negative. I'll just double check. Double check that. So if it's left of the mean, I think if it's left of the mean, we have to use the negative z table. So I accidentally used the positive one, but the negative one is the complement of that. So we should have had to do a 1 minus in the formulation to get here. So if this here, this red shaded area, is what I'm talking about, if this is left of the mean, we have to find the z-square as normal and then do 1 minus because it's left of this mean here in the middle. And then that should change our carried error, and the process should be the exact same, and then we should get the final answer. So I think if we do that correctly, the mu we end up with should be I think it's around 87 k's an hour. Yeah, it should be around 87 k's an hour. I think it was a bit suspicious when it was below 75 and above 100, but that's just interpretation of z tables. So hopefully you guys know how to do that, and then you can use my process for the rest to find the solution, and it shouldn't be too hard. But that should wrap up the stream today. So couple of errors on the way, but that's the whole point. Hopefully you guys don't make them because your ability to interpret questions should be better than mine because I haven't done any practice problems leading up, so my context is lacking compared to you guys. So hopefully your interpretation's better but I think with my general math ability, my working out and general processes should be spot on. A couple of shortcuts to note throughout were when working with the PDF functions, because they're continuous and you're going to take an integral, make sure you set the boundaries properly rather than doing what I did and having to do different integrals and subtracting and minus them. You can just take the first integral and set the boundaries correctly. So that was a nice shortcut. And I think that was the main shortcut. I think the other thing, if you're watching this, to keep in mind is you guys should know what's to be reasonably expected of you. So if it seems too hard to do by hand and it's in the calculator section, I like that's up to you guys to choose whether to just do it calculator. I'm just doing it by hand because I don't know what they expect of you, and I'm just used to doing those things by hand, and then using calculator at the last second. But don't be afraid to just hop on the calculator if you think that's reasonable to do so. But yeah, thanks for watching, and good luck.